Hey everyone, this video is a quick tutorial to either tell you if you missed class on Thursday and Friday, the 14th or 15th, or remind you if you were in class, how you need to go about setting up your screen and then navigating the resources that are available to you for completing Explore 3 Holes in the Earth from Geoscience Processes. So right now, what I have on my screen, of course, is the assignment in STEM scopes. So this should be on your assignment list. And it will look like this. It'll say Explorers 3, and you'll have a bunch of pictures and a whole lot of reading. What I have done in Google Classroom here, and this is fifth hour, thank you, fifth hour, is I've given you obviously the link to STEM scopes here, this ALI global login. These two links to Google Earth I've had sort of mixed success with. So I'm not sure if those are going to work well for everybody, but those are really there just as a bonus. So if you want to try to click around on them, you can. It's a nice idea, I think, to go ahead and have Google Earth open so that you can go visit some of these places there and look around. And then this, however, this slideshow is what I'm really going to be focused on for this presentation. These slides were what we used during class to go over that. So I am going to actually click on that and open that up. Okay, now the thing is, you can just leave your screen like this if it's what makes you most comfortable, but I do recommend that you split your screen so that you can see the slides in one side of the screen and your Explorer in the other. So I'm going to go ahead and pull my slides. I'm going to grab onto this thing and just pull it down so it's a separate window. And I'm going to use my keyboard stroke to make it into one half of the screen. So I'm going to hold down the Alt key and the bracket key that is on the right side just above my Enter. So it'll go like that, and I'll hook it right there to one side of the screen. And then I'm going to do the same thing with the other one, but I'm going to use the other bracket. So now I have them side by side, and I can see both at the same time. The other thing that's always helpful to do when you're trying to look at slides or a video or anything while you're trying to do your assignment is to go ahead and put it in presenter view. And remember that you don't want to just click present. You want to go hit the drop down and click presenter view because what that does is it'll keep it inside a window instead of making it full screen. It will pop up this other window, which you can just go ahead and close. It's not really needed. So that'll just leave that there. So here we have our slides, and then I'm going to go here to STEM scopes. And you might have to move this over a little bit. I'm going to get rid of these little toolbars. Okay, so what we have then is a three-part, well, actually sort of a four-part because you have a CER. In the first part, we're talking about these two craters. One of them is called the Barringer Meteor Crater, and the other is called, and we really argued about how to say this, but I think it's Chicxulub. This is a crater that's located just off the coast of the Yucatan Peninsula. Some of it is faintly evident on the land. So in each one of these, there's a scenario that tells you a little bit about it. And here in the slideshow, aside from the bell work and the usual things, what I've done is I've kind of pulled out some of the major points. So for example, the Barringer Meteor Crater, we know it happened about 50,000 years ago. The meteor weighed probably in the neighborhood of 300,000 tons, and that it was made of nickel and iron. It hit the Earth traveling at approximately 26,000 miles per hour, and the resulting crater is about 3/4 to a mile deep and about 750 feet. Nearly a mile wide and 750 feet deep. All right, so what we're going to do is we're going to come down here to this little, to this chart that we have, and what you want to do is as you read through this, anything that stands out to you. So if it stands out to you that it was 50,000 years ago, you can write that down here. You know, it struck Earth 50,000 years ago. Okay, and you want to make about 2 or 3 observations based on what you see here. And those observations can come from the text, but they could also be observations from the image as well. And remember that you can click on these images in STEM scopes to see them up close. So that'll give you a clear view. Now, what you're seeing here, this is actually the north side of the crater. And this is a road, and this is a parking lot. So that might give you a little bit of a sense of the size of it. But this is another reason why having Google Earth up is not a bad idea. So if you go to Google Earth, obviously I use a lot, so it's right there. I don't know why it always insists on opening in a second window. But what that allows you to do is kind of navigate around in it. So I'm just going to demonstrate that real quick because I think it is worth doing. Just because if nothing else, it's just neat. It's fun. So So once you have Earth open, you can click here. You can type Barringer Crater. There it is. With their meteor crater natural landmark. So this is going to zoom us away from, I guess I was in Spain. I'm not sure why I was in Spain. Okay, so here we are. Here's the crater. Okay, so now that we've seen it, and I close out this little panel so I can see it up close. Now this looks at it straight up and down. You can zoom out, but there's that same visitor center. You can also click 3D and see it kind of at the side, so it gives you a better sense of scale. And I think if you hold down Alt, you can even turn it around so that you can kind of orient it however you want. I think I'm holding down Shift. But, notice that you can zoom way in. You can really get a good sense of, see, there's the parking lot and cars. This is actually a pretty huge visitor center. In addition to that, the other thing that's kind of fun to do, and I'm not going to do a lot of this, but it would be worth it for you to try it, is you can always grab your little dude here and you can move him around and notice that there's a trail that goes all around the crater, but there's also some spots down in the bottom where you could stand him. Some of those are just picture spots that people have taken. And now it's as if you're standing down in the bottom of it. So now you can kind of see, although I'm not sure where we landed here. We ended up on the edge somehow. But that's the idea, and then when you're done with that, you can go click out here to go back out. Somebody had their photo in the wrong spot. Anyway, so that gives you a little bit to play with there. But these you can make observations based on this. And I think mainly what you want to notice is just how defined it is. This crater is remarkably untouched because of the landscape, and it'll talk about that in the text. So do make sure you read the text. Don't just do this and then think you've got it good. You do need to read the text to learn about the environment that it landed in and why it looks so well defined. This really looks like this crater could have hit like last week. So that's something to think about. Then you're going to do the same thing. Let me click out of that. With this one. This is the Chicxulub crater. And again, you can do a search here for that as well. What's that? I think that's how I spell it. Yeah. And you can also use this to go down there. Very different environment, very different conditions, and also a much, much older crater. So you can fiddle around there and look if you want. It's a little bit harder to see anything here because it's so much older and it's also located off the coast, really. But it's good, nice basis for comparison. So you're going to do the same thing here, where you're going to read about it. Again, there is another slide that also kind of distills down what's written here in scenario 2 into a couple of bullet points. This one happened 65 million years ago. In fact, this crater is the one that we believe may have been the precipitating event for the end of the dinosaur age. So it was right here, right off the coast of Mexico. It created enough climate change that it made it difficult for the dinosaurs to survive. And so we think that about 75% of species died at that point. Anyway, so this is, so that's what you're going to do here. Then you're going to come down here, you're going to answer these questions. So one, you're going to answer, how are they different? So again, you want to look at what you noticed about one, what you noticed about the other, and find 2 or 3 differences. How are they the same? Find 2 or 3 similarities. And then, did the impact event happen quickly or slowly? So think back to when we met in class last week and we were talking about events like volcanic eruptions or earthquakes, where you have sort of a long buildup that ends with a very sudden and cataclysmic end, versus something like weathering erosion, where what you have is more of a continuous process that causes large change over time, but it's so gradual that you wouldn't notice until you look back over a long time. This is an event that typically is a pretty sudden, catastrophic event. So you want to make sure you say that here. Did it impact the local region or the entire globe? This is different depending on which crater we're talking about. Barringer will fit one, Chicxulub will hit the other. So you need to tell me which one impacted just the local area, which one impacted the entire globe. And then finally, the Barringer meteor crater is located in the desert in Arizona, and the Chicxulub crater is located on the Yucatan Peninsula, where the climate is that of a rainforest. It is half in the water and half on land. What do the locations of each crater tell you about the geoscience processes that have shaped them since the impact? Now, in this video, I have not really delved deeply into that. I've kind of touched on it a little bit, but you may need to go back up and reread the scenarios, find out where each of them is located, and explain how their location might impact how they look today. Okay, so that's question 5. Then you're going to do the same thing again. And here I'm going to move on. Yeah, see. And I'm going to go to volcanoes now. Okay, so for part two, we're going to be comparing Mount St. Helens with another volcano called Peracutine. Peracutine? I think that's pronounced correctly. I don't know. The Mount St. Helens, I actually remember because I was about 6 years old when this erupted, and I was a little kid, so I didn't have a complete understanding of what was going on. But I did know enough to be a little bit scared because the adults around me were talking about the fact that there was ash in St. Louis that they thought was coming from the eruption. So to me, that meant that this volcano was happening somewhere nearby. But in fact, it wasn't. It's located up in Washington State. So again, uh, you're going to read scenario one. It's a little bit long. And just remember too, if reading this feels real onerous, remember that this tool is here. So click on it and it'll put a little play button up there and it'll read it out loud to you. So if you're, if you don't, if the reading feels onerous to you, you can have them read it out loud to you too. And again, remember that you can click on this to see these pictures up close. So this is Mount St. Helens before it erupted. This was a widely circulated news picture of all of the dust that went up into the atmosphere. And then this is what it looks like from the side. And once again, I also recommend going here, Mount St. Helens. There you go. Because it is also really cool to play with it in Google Earth as well, because you can really see the crater that's resulted. You can see like this is where the mountaintop fell in. It actually exploded out this way, which is kind of cool. It's very different. You can really see where the lava flow is. And just like before, if you want to see it in 2D, you can, but you can also take your guy and you can put him on different spots on the mountain. So like this is one of the higher spots. Actually, I think right about here might be the highest spot. So you can stand on the top. Come on, it'll work. It's telling me no street is available there, but it is. You can see the little dots. There is photograph spots that you can study. People have stood to take pictures and stuff, so you can kind of get a sense of what it would look like if you were actually standing on the ridge looking down. So yeah, see, somebody was there with a friend. Anyway, so totally worth exploring around and doing. It makes this really, kind of makes it feel a little more real to me. But anyway, so feel free to do that. Then you're going to go visit another volcano called Paricutin, which is in Mexico. So again, you can do that here. Good exercise in spelling things correctly that are unfamiliar. Okay, so this is a much smaller, much newer volcano. This one erupted in 1950, I think, roundabout. And again, that's all explained here, 1943 through 1950. So for about 9 years, actually, I think 1952 is when it stopped. So again, you can click here and you can see some of the photos of it. And of course, in the slides, there's a slide about it too. So again, this is one that kind of formed out of nowhere. This is kind of a cool story, although I'm sure it was very scary for the farmer on whose land this just miraculously appeared. But basically, it went from a flat field to a volcanic cone in like about a day and a half. And then continued to erupt for about 9 years. So when you look at it on Google Earth, you can really see, and here I'm going to hold down Shift and drag it around a little bit so you can see a little better. So you can see all the lava flow from all those 9 years. And this is a recent picture. This was taken probably 2020. So, that's how it looks today. And just like before, you can take your guy and you can walk around on parts of it too. So once again, you're going to come down here, you're going to make 2 or 3 observations. I'm going to shut this off just to get rid of those buttons. Make 2 or 3 observations just about Mount St. Helens. Then you're going to make some observations about Paricutin. And this is what we did in class. So we did these together. And then you're going to, once again, tell me how are they different and how are they similar? Do they happen slowly or quickly? Okay, and you'll find that out. If you aren't sure, you can read about that up in the scenarios. And then do they affect the local area and the entire globe? So this is another one where one of them affected pretty much just the local area, but there was one that affected the entire globe. All right, so that's the volcanoes. Okay, so then you can also go visit there. All right, so the plate tectonics section is largely drawing off of the conversation about the volcano. So we're going to kind of look back to what we talked about last quarter. First of all, I want you to notice here that we have Mount St. Helens on the map in Washington, and notice that it's very near a particular ocean here. And by the same token, here's Mexico, and here's Paricutin and a couple of other volcanoes down there. And notice that it is also nearish to a certain ocean. Okay, so hopefully when you look at this map, this will at least seem somewhat familiar, because here's the North American plate, and notice that this is about where Washington is, and this is about where Mexico is, and we are all on this big brown plate here, which isn't actually as long as skinny as that. It's just that this isn't a globe. But the point is, we are all located on the same plate, and this plate is kind of moving to the left here. So some of the questions are going to ask you about what plates we're moving into that's causing all of these volcanoes and earthquakes. All right, so first thing I want to know is, how are they similar in their location? So again, think about what ocean they're near, what side of the continent or what side of the country that they are found on. What tectonic plates affect these volcanoes? So you want to look here and you want to think about the fact that Washington's kind of right up here and Paricutin is right down here. So you're not necessarily looking at the Pacific plate for these, you're looking at these two smaller plates. So you want to name those. How fast do they move? Now you may have to think back. We compared them to a real specific thing that we said over and over again. But if you need to go look that up, feel free to go look and see how fast they move. It's very, very, there's a speed that you can find that's pretty defined. And then finally, does this movement affect the local region or the entire globe? Okay, well, keep in mind that, any motion here pushes the plates everywhere. So kind of just keep that in mind. Then we're going to go into a claim evidence reasoning. And I have in here given you as many props as I can without actually writing it for you. The thing about claim evidence reasoning is that you're going to start seeing these more and more, like over and over again. They are going to show up as bell work. Sometimes they're going to show up in your tests coming forward. So if you are still fuzzy on what goes in each of those boxes, as is the case, I think, for many of us, it's really important that we practice this. Okay, it's important that we practice and know what needs to go in each one. So in the claim, it's one of the mistakes that I've noticed a lot of students making is that you try to basically give me a whole race statement in there. And race, I know you are working on more in writing and in social studies, but it's where you restate the question, you provide your answer, that's the A, and then you cite your evidence, and then you explain your reasoning. That's what race stands for. Obviously, this is claim evidence and reasoning as well, so it's very similar. However, instead of putting that as using that as the way you phrase a single answer, you're actually breaking it out over three very distinct chunks, and that's where it can get confusing. And I'm seeing us try to write the whole race thing in the claim, and then you don't know what to write in the evidence or the reasoning. So this is the format that we need to follow for this. All right, so what you're going to do, anytime you have a CER, you're going to have a sentence here that's going to ask you to do something. In this case, it says, and it says it here too, write a scientific explanation that supports the assumption that theories and laws that describe the natural world operate today as they did in the past and will continue to do so in the future. So what you need to do is just write this in your own words. Now, I have done that here. These are my words. Your words can look similar, but it's important for you to think about what makes sense to you. How do you say this in a way that you would say, like, to one of your friends or me or to a parent, a member of your family? Geoscience processes that happen in the past continue to happen today and will probably continue to happen in the future. That's what I've written here. Basically what we're saying is just, we know that this is happening. We have no reason to think it's going to stop. So it's probably going to continue into the future. Okay. So that's it. That's all that goes there. There's no because, there's no explanation, nothing. It's just a statement. Okay. Your claim is just a sentence like that. All right. Then when you get to your evidence, and when you're doing a CER as part of an exercise, an explorer like this, your evidence is actually pretty well defined. Okay. So you're going to say, according to part one, okay, and part one, remember, is where we talked about the craters. A meteor fell in Arizona 50,000 years ago. Another meteor fell in Mexico 65 million years ago. And that's it. I don't have to say anything else. I know all I'm saying is that there was one that happened a long, long, long time ago and one that happened a little more recently. Okay. And then part two, what did we learn about volcanoes? Well, we learned that there was a volcano that has been around about 40,000 years that just erupted not too long ago. And there's another volcano that formed out of nowhere in the 1950s. Okay, so they formed a long time ago. They're still erupting. We have some that just formed real recently and are still erupting. And then finally, in part 3, what do we learn about plate tectonics? Are they moving today? We know that the plates are moving today. And we know that the plate tectonics that existed in the past are continuing to happen today. They're still moving around. All right. So that's your evidence. It's just stating facts from each of the sections. You're not providing any connection between that and your claim yet. You're just stating what you learned. That seems relevant. Then finally, in your reasoning, you're going to start your sentence with, this tells me that. This tells me that. And I started with the meteors, that if meteors could fall in the past and are still out in space now, they could probably fall today or in the future. So there's no reason to think that that wouldn't continue to happen. Now I'm going to go on, you're going to want to make a second statement about your volcanoes. Same thing. And then talk about the fact that plate tectonics plays a role in where they form. So that is where your reasoning goes. Okay, so this is, again, this part is graded. It is important for you to do it. Don't skip it. But if you do have trouble, make sure, of course, that you let me know. And that is all for this. So at that point, of course, you want to make sure you click save so you don't lose anything that you did. And then, of course, turn it in when you're done. Okay, if you have any questions, give me an email, come by office hours between 1 and 2. Let me know.